Good afternoon, everyone. As Annie mentioned, I'm Stef Waring. I'm Global BDM for SS8, covering Europe and Asia. And with me, I have my lovely colleague, David Anstiss, who is our Director of Solution Engineering. So today, myself and Dave are here to talk to you about kind of 5G location technology, why it's used, and how location technology is used. So 5G represents, I suppose, a huge leap forward in network location, allowing for an accuracy all the way down to 5 to 10 meters within dense areas, which is equivalent currently to GPS accuracy. This is a tenfold increase over the best accuracy available today in 2 to 4G networks. So 5G will not only help to save lives, but also time and money. And hopefully this presentation will show you how and answer a lot of your questions. As Annie mentioned, we will have time for questions at the end, and we welcome all of those questions. So today in, I suppose, mobile network location, you've got three types of accuracy. You've got your standard accuracy, better accuracy, and the high accuracy in which we're going to discuss today. So as I mentioned earlier, network location has greatly improved over the past few years. It's down to a 10 to 50 fold. The technology is independent of the type of device or network generation, so either 2G, 3G, 4G, or 5G. There is a perception that still exists that a mobile network will only ever provide standard location. However, high accuracy is enabled by standards like 3GPP, ensuring all networks can provide this measurement capability. So obtaining a high accuracy location in 5G networks, we start with the primary cell, which is attached to the target or the target mobile device. We then take measurement readings from other surrounding cells, and we're able to calculate the location of where the target or target mobile device is or was. So this is called multi-cell round trip time, or MCRTT, which I'll get into in further detail in another slide. So with this, we can get down to about 5 to 10 meters accuracy from what we've seen in 5G network density. So by utilizing multiple cell measurements, we can provide a very high accuracy without the need of having access to functions or features on the particular phone itself or the device. Currently, the only way to achieve this level of accuracy is to obtain a GPS reading from the phone, which requires access permitted by the actual user. So in terms of the positioning architecture, so 5G, 3GPP standards allow for the use of advanced algorithms, like I mentioned earlier, MCRTT, or multi-connectivity round trip time. So the location management function, or the LMF, which interacts with the management function at subsequently G node B. 3GPP helped here to standardize these positioning methods, which is built into the 5G standard. So our LMF is built to fully utilize these 3GPP standards to obtain all of these high accuracies. So as you can see on the system here on the screen, I've listed out a couple of positioning methods that we have, and we'll focus solely on the ones that are connected into the 5G networks itself. So as I mentioned earlier, the multi-cell based positioning uses signals from multiple cell towers to determine the actual device's location more accurately by calculating its position. So multi-cell round trip time is a method where the device, the UE, and the base station GNB measure how long it takes for a signal to travel from one to the other and back. So these measurements, both on the device and the base stations, are sent to a location server, which then uses the timing data to figure out the device's actual position. So angle of departure here, as you can see from the graphic, you've got the spotlight graphic that's coming from the antenna. These spotlights are like multiple frequencies, and what we've seen in 5G technology is maybe 24 to 48 frequencies, which are reaching for the location information. So this gives us the high capacity and the lower latency. There's another term, and it's called beamforming technology. which this graphic actually depicts. So beamforming technology allows not only much higher accuracy, but the ability to measure the Z-axis, allowing you to identify which floor a person is located in. So as we see here, the device measures the signal strength from each beam, or GNB, and the data is used to determine the angle of arrival based on the device's beam location. The base station measures the angle of arrival of signals from the device based on its beam and sends over the data to the location server. So if we have an angle of departure and the one arc gives us an almost precise location, and pinpoint the location of the actual device. So there are two types of underpinning technology within the strategic location technology, and they are active and passive. So your active is your real-time location, and that allows you to view the device moving on a map in real time. In 5G, this should be sub 1 second if it's implemented correctly. The passive then is your bulk data location, your historical, your mass surveillance. And that allows you to view the location historically and to also draw an area on a map, an activity within inside that area. We call this area a geofence. So just in terms of the SSA product overlay, okay, so in the event you have identified, the law enforcement agency or border control has identified a cluster of devices that's approaching the country or the border. The question is often, have you successfully apprehended the oncoming cluster? If yes, we go ahead and we use the passive element, to which we can detain the migrants, we can perform a phone dump or a device dump and analysis of the phones or devices, and subsequently provide intel to the law enforcement agency to successfully apprehend. If the answer is no, we go ahead and we utilize the active element by identifying the devices, obtaining a warrant, and then we can actively track that target mobile device. So often you'll see specialist officers or tactical teams dispatched to the site or the point of entry to intercept or successfully apprehend there and then. So I suppose we'll get into kind of location intelligence specifically around border control and why it is particularly used. So as you can see on the screen here, there's a couple of use cases here on screen in terms of why it's used. So location technology is used for the use cases we see here on screen and is imperative to the border control officers, especially with what's unfolding in the world at the moment, unfortunately. 5G high accuracy can provide the real world benefits for the border control officers and can speed up that investigative process by mitigating the kind of risk at its source and as soon as possible. SSH, we've actually been in the location industry for over 18 years, providing a voice and solutions to lots of authorities, including emergency services around the world. This includes us on the advisory board of ENA, which is the European Emergency Numbers Association, and we've sat on that board since 2011 and contributed to those standards. So we provided the architectural and the best practice recommendations and helped audit the actual location accuracy of AML. So I suppose the question now is how. So today, using standard cell level accuracy, that could be anything, 500 meters within cities to 20 kilometers in rural. Border control officers are very limited by the technology, but 5G could actually transform many of those investigative processes. So as I mentioned earlier, geofences can be very accurate. For example, you could be drawing an exact shape around key areas, such as particular coastlines or ports of entry, and the ability to accurately detect devices hidden in vehicles along with contraband in real time is imperative here. So identifying this illegal immigration. So here's an example, currently. So there is a big challenge in the UK at the moment for Border Force to try and track the illegal immigration on the south coast of England. This is not only limited to the UK, as we've seen with lots of countries across Europe facing the same issues currently. We see here that there's an example of an actual geofence mapped which can be drawn along, you know, the south coast of England. And you can exclude busy ports and focus only on areas where illegal entry usually takes place or where the border control officers have been tipped off. So it allows us to identify particular vehicle or transportation modes, and how do we actually identify the mobile phones or the devices, etc. So 5G high accuracy would allow the border force officers to identify patterns, excuse me, where the migrants where they're entering, and the exact time. So this example here shows a remote area in the east of Hastings in the UK, and migrants can be seen entering the country at 3:41 in the morning AM. So as you can see here from the slide 2 on the heat maps, one is actually where they arrived and subsequently where they departed from. And then a direction of travel is depicted. And then we get an arrival point. So on this slide here, you can identify, and you can see from the blue kind of arrows along here, these are the cell sites plotted along, okay, from the area of arrival to the final destination. And what we're getting here is, you know, you can get anything from, you know, historical logs, and these can be anything from CDR records. So the border officer would receive an alarm when a group of individuals enter outside of the main port, but also during the early hours. So they would be tracked as they travel to their final destination. And ultimately then the specialist officers or the tactical teams are dispatched to capture both the migrants and their criminal couriers, essentially. So in addition to the information from the cell sites and the CDRs, we can actually also ingest into our solution the ANPR and the CCTV information to pass all of that intel on to the law enforcement officer, and they can actually go ahead and draw up a pattern of life around the subjects of interest. As you can see here, we can identify the exact route taken via ANPR, where they stop to refuel, and we gather the CCTV information from there, and lastly their arrival location where a tactical team were dispatched. So all of this can take place in a relative real time to allow border control officers to be proactive and to prevent that criminal activity. So as I mentioned earlier, the border officer would receive an alarm when a group of individuals enter. And they can continually be tracked, and it will, you know, speed up that investigative process then essentially for the officers. So in summary, we have here that, you know, we have, I suppose, shown how the 5G improves the network location accuracy, and note then in terms of device independence, location accuracy, it is achievable on any 5G device, whether a GPS is available or not. So thank you very much. Here are our contact details. We'd be happy to continue conversations offline, but we would welcome any questions that you have at the moment.
Thank you, Steph. So we have a question from the audience, and Benjamin asks, what is the advantage of location services from telecom networks over the location services that UEOS can provide?
Can I take that one, Steph, please?
Steph might go on for you, right? David, I suspect.
Sure. Thanks.
No
so it's a great question, Benjamin. Thanks for asking. So firstly, the OS itself is license limited. So if you work with Apple, Google, or the Android operating systems, only in emergency services conditions will they allow us to be able to effectively get an accurate or a GPS location from the device itself. What we're talking about is being able to do mass intelligence gathering for regulatory compliance and for the ability to provide that data. The thing that 5G is enabling us to do here is actually get the same or practically the same level of accuracy from the network stuff in near real time passively or real time actively from the device. So it does have a significant helpful point for us. A bit like the CDR records that Steph was mentioning earlier. We're actually able to enhance that from a cell site level down to a very, very specific, you know, 10 to 100, maybe 200-meter range, which is incredibly helpful for law enforcement, and it really helps with border security. So I hope that answers your question. If it doesn't, feel free to ping me, and I'll happily take it offline with you and go further with that. But yeah, great question. Thank you.
Okay, I've got a question for you. Not sure which of you or both of you might have an answer for this. Do I need to have deployed 5G standalone to be able to get this level of accuracy that you're talking about?
Yes, indeed you do. The 5G LMF can only be deployed in a 5G SA network. The 3G methods needed for the 3D positioning are supported via that LMF capability. So yes, unfortunately, it's lovely having the radio access network, but we need the 5G core to be able to deploy that.
I'm just wondering as well if you've got a sense with 5G SA that finally we are getting good progress and more operators deploying it. Is that your sort of perception of the market?
Yeah, from what we're seeing, there was a big uptick in the US to start with. They went hell for leather. The UK is following suit now. We're getting more and more integrations with true 5G cores. And there's obviously different ways of deploying a 5G core network, but the actual SA method that we're talking about is being well upticked, and we're seeing a lot of that in Asia now. Not so much in the African countries, but Singapore and places around there. They're starting to increase their data speeds as much as they've still got legacy 2G networks and 3G networks. They are in the more IT-centric hubs actually starting to deploy 5G SA, which is really good.
And also, what about GPS and Wi-Fi and other device-based location methods? Aren't they even more accurate? And they don't need 5G SA either.
No, that's a very good point.
Sorry.
That's a really good point. And again, yeah, they are in most cases more accurate, 100%. But the handset-based methodologies that you're talking about are typically not for non-emergency cases, i.e. the device blocks you being able to do that unless the user gives you permission, or in an emergency situation, E112, 999, 911 call. And in those instances, the handset will allow the positioning to be provided. But we can't use that for mass or geofence collections. We can't use that for stuff. So yeah. So
okay.
Really
and these days, how accurate is 3D positioning in 5G?
Good question. So we've actually done some trials with this, a couple of carriers, US and UK based, and we're actually seeing some good stuff. I mean, if you were to take the active beam forming capable antennas at a 250-meter range, we can get a horizontal.
David, I didn't hear that properly. Something antennas. I missed that bit. If you take what antennas?
Sorry. So the MIMO beam forming antennas.
Oh, right, yeah.
MIMO beam, yeah. So those type of antennas, if a range of say 250 meters, we're able to do horizontal positioning about 3 to 10 meters and a vertical Z-axis of about 4 to 8. So if somebody's in a building, for argument's sake, we can tell what side of the building they're on and more or less the floor they're on, give or take 1 or 2. So it's actually a really helpful thing, because before you're actually enabling 3D mapping capabilities as well. When legacy stuff was all 2D, now you're actually able to say, well, they're not only this far, we reckon they're in this building and we think they're on the 3rd floor to the east of the building. It gives law enforcement so much more accuracy to be able to find the people that they need to. And it's not just about finding bad guys, it's about finding missing children and being able to locate vulnerable people as well. So it's enabling that through a lawfully mandated approach to be able to take that data.
And is the 3D positioning, I mean, is it well used? Is it something that agencies really want?
They want it. And I'll be honest with you, it's still a little bit in its infancy. Certain mapping companies that we work with are providing the 3D mapping, and it's about making sure how accurate they are, the cell tower overlays, and then being able to fingerprint the cell sites and being able to actually provide that level of accuracy. But yeah, it's something they really want, and they want it really quickly. So yes, it's a big thing for us at the moment.
And how does the looking after the data work? I mean, whether you're chasing people traffickers and illegal immigrants or vulnerable people or children or whatever.
Of course.
I mean, this data is super sensitive. So how do you secure that location data and sort of is it your responsibility? And I'm just wondering as well, presumably in quite a lot of cases, it might be required for use as evidence. So how does that work? And also, you've got lots of different countries and about different compliance about where data is, and increasingly not just where data is stored, but where it travels through.
Yeah, when it transfers, of course. Yeah, it's quite a lot of question there, Annie. So I'll try and walk through it if I can. So firstly, local laws will allow for storage of data. So, for example, most carrier networks will have CDR records as part of their billing, mediation, and revenue purposes. So it's the paper copy, effectively, of the bill. We can use that, or most countries that we work with leverage that capability to identify a cell site from a mass surveillance kind of thing. Well, I say mass surveillance, it's a historical pattern of life. What we utilize is the ability to enhance that cell ID to a very, very accurate level. And then that is then stored and retained for commercial purposes mainly. We leverage it in a slightly different way. When we're doing the active or the real-time, less than a sub-second, where's that person now? I need to know exactly where that phone is and where it's moving to. That's another stream of data that comes in. So there's a lot of security around this with air-gap networks and red secure systems that we store the data in. Data is stored for a defined period before being deleted in line with local practices. We don't store data outside of the country. It's normally stored internally within said country. It's always in immutable logs and secured, so that we have a raw format and then a pre-processed format where we've analyzed the data. So if we're asked to go to court or provide the data to court, you can show the raw format so it can be checked against the algorithm as to why we know the particular phone was in this particular location. So it's all reverse engineered, the math's all available, so that when people do actually go to court, it is irrefutable that the phone or the device was in this particular location, and the degrees and margins of accuracy. So totally, we're very stringent about that. We do have different company profiles for different things. There's a lot of obfuscation with GDPR, and the ability to geofence and find random phones. So yeah, there's a fair lot that goes on in the background, and there's a lot of build up to it where we have to mitigate the risks, and we work with the local government, law enforcement, and the agencies and the telco providers to be able to meet their levels of assurance with antivirus software and the like, on top of secure encrypted databases, on top of VPN connections and encrypted links to and from. So there's an awful lot of checks and balances with full role-based access controls to stop, me checking out where Stef's phone is all the time. There's checks and balances in place whereby people are audited, everything is recorded, and as I say, there's oversight that's not just that comes from different areas. So there's a full visibility, even though the system is secure and robust in that manner.
So you're disguising really in a good way a huge amount of complexity.
Yeah, it's nice. You just go.
Your users don't have to get raveled up in all that. Okay.
Yes, of course.
Thank you very much, Stef and David. It was a pleasure to have you. Thank you very much.
No worries. Thanks for having us.
Interesting stuff. Always so interesting. Thank you very much indeed.
No worries at all. Have a great day. Take care.
Thank you for your time.
Thank you.
Bye-bye.